recording yet. So now we're recording. So
I see it now. Okay. So Tom and I were just talking about lab reports. Obviously, your most current one, that one will remain open. But if you haven't done lab reports 1 and 2 already, I'm going to give you till the end of the week to get those in and or make changes. Because if you remember, I said that if you go by the rubric online, you could make changes to those first couple lab assignments if you weren't happy with your grade. So make sure that all of that's done for those first few labs by the end of this week. Otherwise, I'm going to go ahead and put a 0 there. So just want to make sure everybody's aware of that. So to stay on top of assignments. Actually, kind of while I'm on the lab report topic, I just want to make sure again that everybody has seen that rubric for lab reports that's on Blackboard, because I really would hate for you all to lose points on the lab reports. They're really, really easy, but some people are still giving me 4 sentences, and so there's not a whole lot I can do with that. If you're not completely following the rubric, I have to take points off. So just be sure that you are following the rubric, and again, you have to the end of this week, and if you're not happy with your grades on your lab reports thus far, if you want to take the time to redo them, I will be happy to regrade them, but just make sure that you are following that rubric. Does anybody have any questions about that? Nope. Okay. Does anybody have any questions about exam 2? I know that Tom's probably handed those back by now, and all of your grades are online, and the key was posted. Was everybody able to see the key okay? Any questions? Is anyone talking, or it seems like my thing is picking up something? Okay.
There's a welding class across the hallway just grinding some metal, but
oh no, it's very, very muffled, like voices. I don't know how it's picking that up at all, but I wasn't sure if somebody was talking or not.
are you listening in on your neighbor's cell phone calls?
I don't know. That's weird. Okay. So, well, if no one has any questions about that, then I'm going to go ahead and get started this morning. And then first of all, I was going to ask, do you all feel good with the Pearson square, or do you want to do another example while you have me live? Because I'm fine to do another example. What do you think, Tom, after last class? Do you think we need to do another example?
I don't know. They sort of got it, and after I played your recording of that problem, and then we ended up talking. I paused it, and then we talked about it a little bit more, and I think everybody was happy. But,
okay. All right.
But if y'all want another one, ask now or speak now or forever hold your peace.
Yep. If anybody has a burning desire to do one, we can do one before. If we get to the end of the lecture and you decide you really want to see one again, we can do that too. And then I'll probably do one when we review for the exam as well. So if everybody's good on the Pearson square, then I will go ahead and get into the lecture. All right. So today we're going to cover Chapter 17, which is on animal growth and development. So again, this section as a whole is pretty deep into science and the biology of things. So it's going to be a lot of information again. This whole section is. So if you have any questions at all while I'm going through, feel free to stop me. There's going to be some new terminology and things like that. So if there's something I'm not explaining, just ask me again and I'll try to explain it in a different way, because I know not everybody learns exactly the same way. So I'm happy to explain stuff if you don't understand. So just to start out, talking about growth. Growth is a complex of biological processes that will lead to a mature animal. So it's very, very important to the production of meat by livestock as well as performance of horses. It's important for all animals really that are going to be doing anything. So there are 2 types of growth. So growth happens on a cellular basis. So you're going to have a growth of cells from the time that animal is even like a small embryo. So the cellular basis of growth has 2 distinct processes or distinct types of growth that can happen. So one type of growth would be an increase in cell number. So those cells are just going to be splitting and dividing, and you're going to have a lot more of them. And so that's called hyperplasia. And then the other type of growth that you can have would actually be an increase in cell size. So the cells themselves are actually going to get bigger. And so both of these will happen when you're going to have growth in an animal. So that increase in cell size is called hypertrophy. And so I don't know if this is going to help you at all, but the way that my high school biology teacher taught me to remember these was that trophy, you kind of think of like large trophies, right? Like you want the biggest trophy. So that would be size. So increase in cell size would be hypertrophy, and plasia would be increase in number. Not sure if that helps you at all. She told me that in high school. I still remember it, so it helped me remember it. I just picture a big old trophy, and I know that that's cell size. So hopefully that will help you too. But you can see on this slide on the right, this is just kind of a visual representation of what would happen. So cell hyperplasia, you see that they're staying the same size. You're just getting a lot more of them. The cells are dividing. And then with hypertrophy, you have the same number. They're just actually getting larger themselves. So how do we measure growth? So growth can be measured in a lot of different ways in different species. So for example, in humans, we measure height and sometimes weight, maybe like with smaller children, to just kind of see where they are in the growth curve and where they should be. So some measures are overall growth. So basically the size of that animal, the weight of that animal. So we've talked about how horse growth is measured by their height in hands, which would be measured at the withers, way back to like the first section. So growth in livestock, poultry, aquaculture species, cats and dogs would be measured by an increase in body weight, or what we call average daily gain. And I would say average daily gain would probably be definitely more for the livestock species. I don't think people actually really calculate that for their dogs and cats. You definitely take their weight when you go to the vet to see how they're coming along, but nobody really keeps track of that, I feel like. So yeah, major growth in livestock is going to be looked at by what's called average daily gain. So, of course, growth and average daily gain are kind of overall just like really kind of rough measurements. Average daily gain is a little more specific than just their overall weight. But there are some techniques that can provide more specific information on how that animal is growing. So some of those would be a serial carcass analysis, the use of isotopes to measure rate of synthesis of protein or fat. So basically isotopes are they're kind of a compound that can be put in the feed that if you sample, or if you have a sample of something, you can see if that's in there, and you can kind of determine how fast that isotope was absorbed. And it could be either attached to a protein or a fat, and then that will kind of tell you the rate of synthesis of protein or fat, because it's just basically a compound that you can trace in the animal. So there are other non-invasive methods such as ultrasound. Ultrasound is used for, obviously, to preg check animals sometimes. It can also be used to measure like 12th rib back fat and things like that, to kind of see how close that animal is to its full growth potential or to go to slaughter. Electric impedance and magnetic resonance imaging, which would be MRI imaging, which you're probably familiar with, to determine the composition of a live animal. So that will just kind of tell you more like what their amount of fat versus muscle is, things like that. Nitrogen retention is another measurement that you could look at. And then there are actual back fat probes. Like I said, you can look at the back fat on that animal and you can tell different things, like with pigs, you know, are they ready to be bred? Do they have enough back fat there, or are they ready to go to slaughter? So lots of different ways that you can measure that stuff. So something that we use to determine growth of animals, or kind of how we feed them at least, and to kind of think about their growth, and there's a growth curve. So this is basically, sigmoidal is just the type of curve that it is. So you can basically just call it an S curve because it looks like an S if you're kind of looking at this picture here on the slide. So that will actually depict growth through an animal's lifetime. So basically, just to kind of break this curve down, the reason it's S-shaped is that you have conception here. So you've kind of got like somewhat slow growth until while the animal is developing during gestation. Then you're going to have birth, and you're going to have, from birth to maturity, you're going to have this rapid area of growth there. Like you can see that line just shoots up because that animal's growing so fast. However, and just like in people, you're going to reach an age and they're going to reach an age where they're going to become mature, and that rapid growth is going to start to curve off. Because they're going to start maybe putting on more fat. They're kind of done with that rapid bone growth and muscle growth. And so that is going to kind of plateau up there. So if you just think about growth, then it's just an S-shaped curve. And so that's pretty kind of easy to just draw out and kind of see how that would work. So you can kind of further break down the growth curve into a little more specific sections. So you're going to have growth of organs, but these are going to kind of all occur a little bit differently from each other. So when the organs start to grow, bone is going to be the first one that is going to grow and kind of mature before you start laying down muscle and fat. And that makes complete sense because bone is kind of what gives that animal's body the structure. You have to be able to have muscle to hold that bone in place and everything, but you can't really start building muscle and fat on top of things if there's no bone there. So bone is first, muscle is going to be laid down second, and then adipose tissue will be third. So when you see over here on this picture, you kind of have from birth, you're going to have a slow growth of bone, but bone is going to start growing first. And then you're going to have a lot of muscle growth because that animal, as they get older, they're going to be rapidly putting down muscle. And then again, you see how that kind of tapers off once they get mature. And then the same with fat, but fat's going to be laid down third. But muscle and fat both kind of have that S-shape curve, whereas bone is kind of just steadily increasing a little bit, and then it kind of just tapers off because it's bigger and of the right size. So definitely be familiar with the order of how this happens. I wish that I could help it make it easier, but they're not in alphabetical order. So you're just going to kind of have to learn that bone is first, muscle is second, and adipose tissue is third. So maybe you can come up with some sort of cool, like, something to remember BMA by. I don't know. I don't really have anything for you on that one.
Oh, can I ask a question?
Yes.
For that slide, would, like, I don't know, lungs and intestines and stuff, they be considered muscle?
Yeah.
Okay. I thought they were, but just thought I'd ask.
Yeah, they'd kind of like, yeah. I mean, I would kind of lump them into that category because they're definitely not fat or bone, and like the intestines are a lot of muscle. So yeah, I would kind of lump them in with muscle.
Okay. Thank you.
Yeah. So there are different hormones that control growth because obviously there are hormones in the body that control all the different processes that happen throughout the body. So the principal hormone or the main hormone that controls growth is very easy to remember. It is called growth hormone. So that should by far be the easiest hormone name that you ever have to remember and what it does. So growth hormone, it's also called somatotropin. But for, anything, you can just call it growth hormone. That's easier to remember. And so basically it is a hormone that's made up of protein. So it's a protein hormone that's released from the anterior pituitary gland. And so that's just an area of the brain. And it's under the control of releasing factors from the hypothalamus. So basically the brain, different parts of the brain are going to control the release of growth hormone. And you'll have a lot of different things that can affect that. So growth hormone works by stimulating the growth of bone and muscle, and it does this sort of indirectly by increasing the production of another kind of hormone factor, which is called insulin-like growth factor 1, so IGF-1. I know that one's not as easy to remember as growth hormone. I wish that it was. But so that is actually produced in the liver. So growth hormone is going to be controlled and released by the brain. And so it is going to stimulate the release of this IGF-1 from the liver. And then through that, it is going to actually stimulate the growth of bone and muscle. Does that make sense? So it's kind of like it's a couple step process, but that is really how growth hormone acts. So there are two phases of growth, and those would be prenatal, which would occur before birth. So that's when you're going to have the cell differentiation, which would be the cells that are going to become different organs. So you would have like a bunch of your regular stem cells. Then you're going to have some that are going to become bone. You're going to have some that are going to become, organs or muscle or whatever. So all of that kind of differentiation mostly happens before birth. And then you're also going to have a lot of cell division. So cell division is going to be an increase in cell number, which we just learned is called
hyperplasia.
Hyperplasia. Yep, exactly. So that's all happening prenatally. So before. So the other phase of growth would be postnatal growth, which is going to be growth that's going to occur after birth. So in the majority of animals, postnatal growth is more a result of hypertrophy, which is an increase in cell
size.
Correct. So that's kind of how those come into play, because if you think about, an embryo or fetus, it's going to have to get a lot bigger. You're going to have all these cells that are going to be getting different jobs. So you need a lot of different, you need a lot more of the actual cells. And then once you have those cells that are kind of already differentiated into what part of the body they're going to become, then those cells are going to just start getting bigger after birth. So that's kind of how that all works. Does that make sense? Okay. So now we're going to talk a little bit about sexual dimorphism of growth. And so sexual dimorphism is basically when a characteristic of an animal that is completely unrelated to reproduction shows differences between males and females. So an example would be that there is variation in growth rate within a given species or breed within a species. So there could be differences in that. So for example, on average, males grow faster than females and will achieve a larger mature body size. And the main factor involved in that is testosterone. However, it's kind of a little bit flipped in reptiles. Some reptiles, the females will actually be larger and grow faster than the male. But for the most part, in most species, I would definitely say that the males are going to be larger and they're going to grow faster. So be familiar with what that term means and that definition on this slide. So now we're back to nutrition and growth, because obviously without proper nutrition, growth is going to be stunted and it's not going to happen properly. So you want to be able to reach the maximum growth rate. And in order to do that, that requires optimum nutrition. So you have to be meeting all of the requirements of that animal. If the nutrients do not meet the requirements of that animal, then the growth is going to slow down and it may even actually stop. So that growth of that animal is going to be very, very stunted. There is such a thing as compensatory growth. And so basically this is just rapid growth that's achieved when optimal nutrition is provided after a period of slowed growth and malnutrition. So let's say you have a piglet or an animal that was just born and it's not really getting a lot of good nutrition. It's kind of slowed down. It's not growing as well as the other animals are. And so then all of a sudden after like a week, it gets much better nutrition. It's eating better. There will be a little bit of compensatory growth to kind of compensate for the growth that it lost. However, typically those animals are still not going to reach the full potential that they could have had they not been in kind of a period of malnutrition. So the way I think of compensatory growth and how I kind of remember that term is it's growth that's compensating for that period of malnutrition by trying to kind of get that animal back up to where it should be. But typically, again, they will grow some, but they're not gonna quite catch up with their other counterparts. Does that make sense? So basically, you always want to make sure that the animals have the optimum nutrition from the start so that you're not limiting that growth at all. So other factors that are related to growth, I know you all just had the genetics lecture. So genetics can greatly impact growth and how fast an animal grows and how well they grow, and also kind of what type of growth happens, so whether they lay down more muscle or more fat. So obviously, to make livestock production more efficient, there has been a selection of animals with superior growth rates, because you want animals that are going to grow really fast on kind of as little input as you can give them. So quantitative genetics is just an area of genetics that has accelerated progress greatly in this area. So that's a big important factor for sure. As a nutritionist, I'm also kind of occasionally work with geneticists, and they kind of tell us what changes they've made on the genetic side so that we know how to better feed that animal on the nutrition side, because their requirements change based on what the type of animal they're selecting for. So it's always good to know, if you have a farm, no matter what kind of farm you have, that you kind of know what type of genetics you have and know how that animal needs to be fed. Because even with general, this is how you feed a pig, this is how you feed a cow, if you really want to get down to the specifics, you can kind of feed pretty specific to the actual genetic lines that you have. And that will be better for that animal and its growth. So artificial insemination allows for the selection of superior animals to use for breeding. We've kind of already talked about artificial insemination and why it's important, because you don't have to have just one animal that's kind of hanging around to breed everyone. You can get great semen that's been checked for quality, that's from a sire that has characteristics that you want on your operation, and a sire that has a lot of data as well. So AI is really, really helpful. So we've talked about stress also in some other lectures, and how stress can impact nutrient requirements of the animal. So it can also impact growth, because if it's affecting their nutrient requirements, then it's definitely going to affect how they're going to grow. So when animals are stressed, the adrenal cortex in the brain, which is just a little part in the brain, produces a stress hormone. And so stress over hours or days, rather than a sudden stress, can kind of change how things are affected. So things like crowding. If you have too many animals in a pen, we see this with pigs sometimes when they start getting a lot bigger and they're about to go to market, they'll start to get kind of crowded. That can be extremely stressful. Transportation can be very stressful, and that can be a very long stress depending on how long it's going to take that animal to get to slaughter. Starvation is another stress. It's biological stress. And so all of those are kind of big deals. We also talked about other things that can stress, like cattle, for example, which would be like dehorning or branding or anything like that. With pigs, we talked about weaning is a stressful period of time. So there are a lot of different types of stress that can all impact growth. So the adrenal stress hormone is a steroid that is synthesized from cholesterol. So there are two cortical stress hormones. And so the main one is cortisol. And so that's the stress hormone that is found in people, cattle, pigs, horses, and sheep. So basically the equivalent of that is going to be corticosterone, which is found in poultry and rodents. So those are the two stress hormones, and they do pretty much the same thing. They are just a slightly different hormone in the different species. So cortisol is typically the one that you're going to hear about most often if you continue in animal science. But if you are kind of going a more poultry-specific route, then you'll talk about corticosterone a little bit more. But they're both stress hormones. So what do? What happens when these stress hormones are produced in the animal? So basically, these hormones will act in the animal's body to reduce growth. So by reduced growth, I mean that they're going to have reduced growth of their skeleton, so reduced bone growth, and they're going to have more breakdown of the muscle proteins. So obviously, if the muscles are being broken down, then the muscles are not being put down in the animal and to grow, because those muscles are having to be broken down. So how you can kind of limit this effect of stress, of these stress hormones, would be with good management. So make sure that you're not overcrowding animals if you have a pen type situation. Make sure that if you're transporting them, that everything is kept calm, that the animals aren't really too stressed if you're running them through a head gate or anything like that. Just overall try to reduce their stress level as much as you can, because that stress hormone is definitely going to kick in, and it's going to completely do the opposite of what you're trying to achieve with growing that animal. There are also diseases that are associated with reduced growth as well. So it's not always stress. There could be diseases that are causing that animal to have reduced growth. So if they're sick, if any sort of disease is going through the barn, anything like that, they're going to be using all their like nutrients and energy to kind of fight that disease off, and they're not going to be able to be using them for growth. So along that line, there are also abnormalities that can happen in growth aside from disease. So these are not actually really diseases. They're kind of just genetic abnormalities. So one of those would be what we call dwarfism. And so dwarfism is basically just a failure to grow at the correct rate and to achieve normal mature weight. So that animal's never going to grow properly, it's never going to grow at the correct rate, and it's never going to actually reach its full size. And so there are several causes of this. So there could be a growth hormone deficiency, because obviously growth hormone is the hormone that controls growth. So if you have a deficiency in that hormone, then you're not going to have that animal reach its full potential. And this is often seen in dogs. So you can see on the right, I have this picture of a German Shepherd dwarf right there. So you see the normal sized one, and then you see this other one on the right. Just doesn't really look like, even its coat you can see is kind of a little scruffy, and it's just never going to be a full-size animal. So that's one type of deficiency that you can have that would lead to dwarfism. Another one, because remember we just said that growth hormone mainly acts through that IGF-1, which is insulin growth like factor 1. So you can also have a deficiency in that hormone as well. So if you have a deficiency in that hormone, what happens is that person or animal will actually have normal growth hormone levels. However, that growth hormone is trying to produce that IGF-1, and that's where the deficiency occurs. You don't have enough IGF-1 to stimulate that growth. So you can have a deficiency in either one of those hormones and still kind of get the same result. So the IGF-1 deficiency is more often seen in people, miniature cattle, and then dwarf chickens. So that's typically the problem that's going on there. And that is a genetic abnormality, so there's really nothing that you can do about that other than just feed that animal and just know that it's not going to reach proper potential. But that's not something that can be fixed with nutrition or anything else. It just kind of happens. Is everybody good on that? Do you have any questions about that slide? Good. Okay. So other abnormalities in growth, hypothyroidism would be low levels of thyroid hormones. So thyroid hormones are essential for growth and development. And we're not going to get into the exact specifics of how they're essential because if you ever take anatomy and physiology, you'll get more into that. So the way that I kind of remember that is that hypo, and it sounds like low. It sounds more like low than high. So hypo means low. And so you may see scientific words that have hypo whatever, like hypoglycemia is another one, so that means low blood sugar. So hypo means low, so hypothyroidism is low levels of those thyroid hormones. So like I said, they're essential for growth and development. So if you have low levels, then obviously you're not going to have full growth potential happening. This can be seen in horses. So the foals will actually show, let's see a space here, show musculoskeletal deformities. So their conformation will kind of be off, and their bones won't really look right. So you'll kind of notice that pretty soon. So this actually could be due, and that should definitely be DUE, to toxins from plants that are actually affecting the thyroid gland. So that's an example of something that is not necessarily a genetic thing. That could actually be something that happens due to that mother or that dam ingesting toxins from plants that can affect the thyroid gland and then could affect her offspring. So other abnormalities would be runting in pigs. And so basically that's just growth impaired baby pigs that show lower rates of growth through weaning and post-weaning. And so there are a lot of different things that cause that. It's basically thought to be due to the uterine environment restricting the growth that they can actually have intrauterine. And so therefore, if they're born a lot smaller, their postnatal growth is going to be restricted. They're not going to be able to compete with their litter mates to get milk. They typically get the teats that don't really produce a lot of milk, so then they're kind of already at a disadvantage, and then that makes it worse. And then they're not going to have a lot of postnatal growth. And this is actually becoming more of a problem in the swine industry now because the females are actually being selected to have a high number of piglets. So actually we're up to some sows that are having like 22 piglets per litter, which is a lot considering that several years ago, not all that long ago, it was like 9 or 10 was kind of average. Actually, what I learned in school in my undergrad was 9 or 10, and now we've got some that are having like 22. But because of that, her uterus is only so big, so you're getting 22, but those piglets, you're having a lot more of the smaller runts. That's kind of a problem that the swine industry is dealing with now, and how to kind of figure that out. So aging. Obviously, with growth and development, you're going to eventually have aging, which is depressing because I'm kind of reaching that age now where, like, past 25, your body's no longer growing as a human adult. So I've been very depressed because I'm now 27, so I'm thinking about aging already. So Tom's probably, like, laughing at me, but it's bad. It's so bad. I, like, get up every morning, like, my hip pops, and I'm like an 85-year-old woman. It's ridiculous. Ever since 25, it's just going downhill fast.
Yes. I have children older than you.
Yeah, I know. My mother-in-law like makes fun of me because I don't want to celebrate my birthday, and she's like, "Oh my gosh, like I'm 60," and you're like, and I'm like, "Yeah, it's really bad after 25." But yeah. Anyway, my husband like makes fun of me all the time, but. So aging has little relevance to livestock actually because typically livestock are going to be sold off and slaughtered before they're actually going to reach old age. They'll be culled or sent to market. So it's not typically a big issue. Where it would be an issue with livestock would be like your breeding animals. Those that can be kept around too long, so you kind of need to know when to cull those animals. And so really those are the only ones where you're kind of going to think of aging and longevity as something that you kind of need to be concerned with. Or like if you have animals that you're I'm losing my words, collecting semen from, so like your boars or your bulls, those animals are not going to be going to slaughter until they kind of are no longer being good at that job or producing good quality semen. So aging might come into play there a little bit, but typically with your market animals, it's not going to be an issue because they'll be long gone to slaughter by the time that would happen. However, aging is a concern in companion animals. And so aging can lead to mental deterioration, reduced muscle, diabetes, or cardiovascular disease. And animals, as I'm sure most of you know, if you've ever had a dog or a cat, they age way more quickly than humans. Like my dog is already like 5 and he's been gray since he was 4. So definitely they age a lot faster. They have shorter lifespans. So kind of a lot could happen to animals very suddenly compared to people. Aged geriatric horses are also kind of another time where aging might be an issue with animals. So if you have a much older horse, you might see a greater incidence of colic, dental disease, tumors, lameness, and pituitary disease. Pituitary is just, again, another part of the brain. So that could influence the hormones that are going to be produced there. So there are different things that can be used to stimulate growth. So we'll talk a little bit about growth stimulators or promotants in cattle. So there are hormonal implants that could be used extensively in cattle to improve growth and feed efficiency. However, these are probably going to be limited, if some of these may not have already been limited here in the future, just because of consumer preferences. People don't like to hear that hormones were added to anything. They kind of lose their mind and don't realize that it's actually not that harmful. But hormonal implants can be used to improve growth and feed efficiency. So you could have hormonal implants that are estrogen, an androgen. An example of an androgen would be testosterone. Progesterone would be another one. That's the hormone that actually maintains pregnancy. And implants have FDA approval in the US and Canada and a few other countries, but they are prohibited in the European Union. And the reason that I say that, we may not always be able to use them is that typically things like that kind of start in Europe, and then we kind of are looking forward to see what Europe is doing. And then typically once they're banned in Europe, the US follows within a few years. So we're following a couple of things with the swine industry right now that Europe is taking out and banning, that we're kind of preparing for, because we know that probably within the next, decade, that's going to be an issue for us. So these are kind of something that with cattle are probably going to come under scrutiny. Oh, I'm going backwards. So there are practical uses of growth promotants. So some advantages would be that the use of these implants can result in a 15 to 20% increase in growth rate, as well as improved feed efficiency. And improved feed efficiency is always really what we want to aim for, because that means that animal's going to grow better on less feed. So it's less input, less cost to the producer, and you're still getting the same amount, if not better growth. So they'll work for either small or large scale production. So you can use them in any type of situation. The disadvantage would be that some decreases in carcass quality have been observed. So like, for example, in cattle, you may have more meat, but less of it may actually be like prime quality. More of it may be like choice or something else. So that is one kind of disadvantage of that. So there are different types of growth promoters that you can have. So just a little bit of terminology, just to kind of get you familiar with it. So an agonist would be a chemical that basically mimics or copies a natural hormone or neurotransmitter that's produced. So if you have, for example, like growth hormone controls growth, this is just an example. You could have an agonist that is exactly like it's made to function exactly like growth hormone. And so then you could actually give that to the animal, and that agonist would actually be able to bind to that receptor and then evoke a biological response. So you could do something like that where it copies exactly what the natural hormone or neurotransmitter does. Another type of growth promoter would be an adrenergic growth promoter, which would be a compound like epinephrine or adrenaline. And so those are kind of going to more affect the nervous system typically, but they can also have impacts on growth. So beta adrenergic agonists, such as growth stimulators and promotants. Beta adrenergic agonists are a specific category of agonists. So remember, we just said agonist is a chemical that copies what a natural hormone does. So some of you may have heard of ractopamine, which was commercialized by a company called Elanco. Elanco Animal Health actually is, I guess, what it used to be called. I think now it's just Elanco. And it was used to improve the performance of pigs and cattle. And so basically ractopamine acts by increasing the deposition of muscle protein and reducing the amount of triglycerides or fat that's deposited. So it's basically just causing that animal to have more lean growth and shift all of their energy towards laying down muscle. So it actually increases the breakdown of triglycerides and will reduce the synthesis of fatty acids and triglycerides. So it kind of works in a few different ways to promote growth. But typically, I know in pigs, not a lot of people actually use this product anymore. It actually kind of made the pigs a lot more kind of energetic and jumpy, and people were complaining about having to actually deal with the pigs and moving them to get onto the trucks to go to the slaughterhouse. The pigs were getting super, super stressed and way more kind of agitated and just harder to handle. And so for that, and then other obviously consumer demands and pressure from the consumers, I don't see this typically being used a whole lot in pigs. It is still allowed, but it's just not something that a lot of people are really using. As far as cattle, I'm not sure, but I would imagine it's probably kind of the same, that probably not as many people are using it anymore due to consumer factors. So this is also another heavy topic that that we face in the livestock industry. That's antibiotics as growth promoters. So they've been used in the poultry and pig industries as antimicrobial growth promoters, or AGPs, for 50 plus years. But the European Union, again, remember I said that what happens in Europe kind of shortly follows in the US. The European Union banned AGPs based on the consumer view that AGPs are responsible for the development of antibiotic resistance. And so that is kind of a really big deal. So as of January 1 of last year, the Veterinary Feed Directive, or VFD, has impacted the U.S. And I think I do have a slide of what that is. So the veterinary feed directive is extremely important to know if you know about if you are raising animals, because it is a rule that's set forth by the FDA that basically states that any drug that is medically important in human medicine can no longer be used in animal feed. So basically, I pulled this information from their website just for your kind of information to give you a view of what this is. So the FDA basically is moving to eliminate the use of, again, medically important antibiotics for production purposes. So it's very important to understand it's just for production purposes, so for growth promotion and feed efficiency, and bring their remaining therapeutic uses in feed and water under the supervision of a licensed veterinarian. So basically, with the VFD rule, if you want to use any of these drugs that fall under that rule, there is a list of them for each species, then you have to have a written prescription from a veterinarian that states which drug it is and specifically how that drug is to be used. So that drug could potentially still be used, but you have to have a prescription, and it can only be used if, like, let's say that animal shows that they have a disease, then you could use that drug. If the animal is healthy, you can't just put that drug in there to actually help them grow. So all of that has kind of come under more control. So if you're a livestock producer, I'm sure you have a good relationship with vets that come out and that take care of these VFDs. And a lot of that will typically happen at the feed mills as well that are actually putting the medications in the feed. The feed mills will work very closely with the veterinarians. So the veterinary feed directive, it's an important part of the FDA's overall strategy to ensure the judicious use of medically important antimicrobials in food-producing animals. So overall, it's a good thing because we want to prevent antibiotic resistance and want to make sure that these antibiotics are not being overused, because if they are overused, then it's going to be a lot harder to treat diseases when those antibiotics are resistant to those bacteria because they've been, or viruses, because they've been around so long. So it is a good rule, but it's something to be aware of if you have animals. You want to have a good relationship with your vet and make sure that you're always abiding by the VFD, because if you're found to not be in compliance, there can be a lot of repercussions. And I just put this website there. For any of you that have any more questions about it, you can go to that website and it'll tell you all about it. And then you can actually find what drugs kind of actually need a VFD. And at any point in time, more can be added. So it's always a good website to kind of be familiar with if you have animals, livestock species. You don't need to worry about it for like companion animals or anything, obviously. So that's my last slide for today. Does anybody have any questions on anything?
When is the test going to be?
Yeah, so that was actually my next announcement after the questions. So good question. So the test is going to be November 7th, which is going to be next Wednesday. So you all need to be like thinking about studying for that and preparing for that. Hopefully you've been going over the lectures kind of, throughout the last couple of weeks, because this is some very heavy material. Actually, after class today, I'm going to be posting an assignment, which is going to be called Section 3 Questions. So this assignment is actually going to be your study guide for the exam. However, because this material is very intense and it is a lot, I'm making that study guide your assignment. So it's mandatory, because I know not everyone always does study guides. But this one, I really feel like you need to do this study guide because you're going to need to get into this material and get familiar with it. So that will be posted after class today. And I'm going to make that due probably Monday of next week. So you'd have a whole week to work on it. That way you have to do that assignment well before, 2 days before the exam. Because I don't want to leave it up till the exam, because then people will be trying to rush and do it at the last minute. So that assignment will be available after class today. So it's just going to be a list of questions that I want you to answer. It's a little bit of a lengthy assignment, but it's worth a good amount of points, and it will definitely help you prepare for the test because it's going to send you to the notes to get familiar with this material. And I would really encourage you, because this material is challenging, that as you're going through that assignment, if you have any questions or anything you don't understand, feel free to shoot me an email so that I can better explain it to you, because this test is going to be pretty challenging just because of the material that we had to cover in this section. So again, Section 3 questions will show up in your assignments after class on Blackboard. it'll have the due date there, but it's most likely going to be Monday night of next week at like midnight is when I'm going to have it due. And then your test will be on Wednesday. And then, of course, for online students, your exam is going to be open for that whole week. If you need a proctor or your proctor situation has changed, again, please let me know ahead of time, and we'll try to figure that out. If you know that that test date does not work for you because something is coming up or you have something scheduled, please let me know in advance because when you come to me afterwards, I don't know why you missed the exam unless there's an emergency or something, obviously. But if anything comes up and you need to miss the test, please let me know as soon as you know, because otherwise I have to kind of do things on my end, and it's inconsiderate to people that actually do show up to the test. So anything with that, have any questions? Okay, everything's good. Everybody feels okay about the material. No questions so far. All right, well, y'all have a good day.
Okay, bye.
Bye.